Hi, everybody. It's Miss Rose. We've been studying similar triangles the last couple of weeks, and now we're going to just look at what happens when you have similar triangles that are embedded within each other. The key for all these problems is you're going to notice that there are parallel lines. If there's not, then you won't necessarily be able to set these up the same way. The nice thing about parallel lines is they give you congruent corresponding angles. So that means what you have is a little triangle up on top that ends up being similar to the whole big triangle because all of their angles are all congruent to each other. So the key is going to be drawing those two similar triangles. So let's check that out and see what that looks like. Let me highlight for you the first triangle that you're going to want to draw. Let's draw this little triangle up on top. So copy it down and just label everything as is. The left-hand side is 80, the right-hand side is y, and the bottom is x. All right, the other triangle that you should see is this whole big triangle. This one's a little trickier to label. If you want to try to pause the video for a second and see if you can come up with the labels for each of the three sides, because it's not as straightforward as the last one. All right, hopefully you notice that the bottom is 112.5, but what do you get on the left-hand side? Be careful, it's not just the bottom number, it's not just 20, it's this whole length, so you have to take the 80 and the 20 and add them together. So you get 100. And then keep that in mind, what operation did I just do to the 80 and the 20? I added them, so that's what I have to do to the y and 25. To combine those. So we can use the expression y plus 25 for the length of the right-hand side. Now that we've done that, that's the hard work. So now that we've recopied it, now we can use our usual method of either using scale factor or setting up proportions to find x and y. I like the setting up proportions method. So I use the 80 and the 20 because those match up with each other. Not 20, 100, the 80 and the 100. And then I'm going to solve for x first. So I'm going to use the x. That corresponds with the 112.5. Then I'm going to cross multiply 100x equals, and then I'm going to grab a calculator and do 80 times 112.5, 9,000. So that's going to work out nicely. 9,000 divided by 100 is 90. All right, let's do the exact same thing, but for y. So I'm going to use the 80 and the 100 again. And then what do I need to set up for the y? Be careful what order you do this in. 80 over 100, small over big. So I have to go y over y plus 25. And then this is like last week where we have to do the distributive property. So the 100y part is straightforward. But this side with the 80, I have to do 80 parentheses y plus 25, which is actually 80y plus, let's see what that is, 80 times 25 plus 2,000. All right, then we'll do a quick solving. Minus 80y on both sides. I'm running out of room here. 20y equals 2,000. So if I divided, I would get y equals 100. Last thing I do is I just make sure that those measurements make sense, because if I accidentally did something upside down in my proportion, I'll get answers that don't make sense. So I look back, x was 90, and it needed to be smaller than 112.5. If I had gotten something bigger than 112.5, that wouldn't have made sense. And then also the y that I got should be bigger than 25, which it is. So that kind of checks out with the picture. I always go back and double check and make sure that my answers make sense. All right, that's going to be the key for this problem set, but I'm going to show you one more example just to make sure that we have it. I actually would argue that this one is going to be a lot quicker and easier than the last one that we just did. So the key is EB and DC are parallel again. So yes, we have a little triangle embedded into its bigger similar triangle. So we can use the same method again. So AD is 15, AB is 10, AC, the whole AC is 25, and then DC is 32.5. One thing that sometimes throws people off in these problems is I didn't give you any variables anywhere. It just says find EB and AE. So just put variables in the picture. Find EB, call it X. Find AE, call it Y. So same thing again. I'm going to redraw this little triangle. Y, X, and 10. Now I'm going to redraw the big triangle. So if you want to pause for a second and think about how each side should be labeled, don't overcomplicate it though. All right, this time we actually gave you all three lengths. AD is 15, DC is 32.5, and AC is 25. So that's one of the reasons why I said this one is a little bit easier than the last one. You didn't have to do any adding. And finally, we will set up our proportions, or you can use scale factor. So the 10 and the 25 match up, so I'm going to use those two. And then I'm going to go X and 32.5. So 25X, 10 times 32.5 is 325, and then I divide. And that's 13. In the actual problem, it didn't say find X though. Remember, it said find EB, so it would actually be better to say EB is 13. And then let's do one more proportion to find Y. So I'm going to use the 10 and the 25 again. And then another reason why this problem is easier is there's no distributing to have to do. I just go Y and 15. And I just do a quick 25Y. 10 times 15 is 150. You divide and you get Y is 6. And that was AE. All right, so go ahead and try the practice problems, redraw those triangles, set up proportions, and let me know what questions you have. Bye.